Welcome to this live stream, and today we are going to learn one of the most important topics from the major phase of the Lean Six Sigma. Today's topic is about the measurement system analysis, and I'm sure at the end of this live stream you will be getting the complete clarity about what is the importance of measurement system analysis and why should working professional have this skill set for their career growth. Okay, so let's start with the learning, and before to start, I just want to explain you the first important topic, which is what is the importance of measurement system analysis in real world, and why it is important. Because if you take any actions into the real world, that actions are based on the data, right? Now, with the measurement system with which we are collecting this data, if that measurement system is not capable, then imagine what is going to happen. The results or the actions that you are going to initiate based on this data will not be accurate, and it is a loss of resources, time and money, everything, right? So that's why it's very important that whatever the data that you have collected or the data on which you are going to take the actions must be accurate, right? That's why we need to understand the importance of measurement system analysis in real world. Now, into the first section of today's session, I'm also going to explain what is the important concepts into this measurement system analysis. And for that purpose, I'm having a very small video on that. I'm going to show you that video. Let's understand what is the importance of measurement system analysis and short introduction of it. And then we will jump into the what are the tools and sequences into the measurement system analysis. So let's start. Please watch this video.
Hello friends, our day-to-day life is largely impacted by more and more data. In business and industry, we are using the data in more ways than even before. When this measurement data is being used to make decisions regarding the process and business in general, it is very important that the data is accurate. If there are errors in our measurement system, we will be making decisions based on incorrect data. We could be making incorrect decisions or producing non-conforming parts. A properly planned and executed measurement system analysis can help us to build a strong foundation for any database decision-making process. From this video onwards, we are going to learn this concept of measurement system analysis and its practical application in real life with examples. To start with, this video is about explanation of all the basic terms used in MSA so that remaining part will be very easy for understanding. So let's begin. Measurement system and measurement system analysis. A measurement system is a collection of procedures, gauges, and operators that are used to obtain measurements. Whereas measurement system analysis is used to evaluate the capacity of measurement system from the statistical properties such as accuracy, precision, bias, linearity, stability, repeatability, and reproducibility. True value, the actual population value that would be obtained with the perfect measuring instruments and without committing any error of any type, both in collecting the primary data and in carrying out mathematical operations. Accuracy and precision. Accuracy is the degree of conformity of measured quantity to its true value. That is, measurements that are close to the true or actual value are said to be accurate. Whereas, precision is the degree to which further measurements show the same or similar results. That is, measurements that are close to each other are said to be precise. Please note that measurement results can be 1. Accurate but not precise, 2. Precise but not accurate, 3. Both accurate as well as precise, and 4. Neither accurate nor precise. Bias. Bias is the tendency of a measurement process to over or underestimate the value of population parameter. To estimate the bias, we need to measure the same part number of times. Then calculate the average of these measurements. Now, the difference between average of these measurements and the true value is called as a bias. Calibration of a measurement equipment helps us in minimizing the bias during usage. Linearity. Linearity is the change in bias over operating range of the measurement equipment. In many measurement systems, error tend to increase with the larger measurements. Stability. Stability is the change in bias of the measurement system over time. Periodic calibration of measurement equipment is performed to assess the stability. Repeatability. Repeatability is the inherent variation due to the measurement equipment. If the same operator measures the same part number of times, the closeness of these measurements is a measure of repeatability. This is also called as within appraiser variation, as well as equipment variation denoted by EV. Reproducibility. Reproducibility is the variation in the average of measurements made by different operators using the same measurement instrument for measuring identical characteristic of the same part. This is also called as a between appraiser variation as well as appraiser variation, denoted by AV. Number of distinct categories, that is NDC. The number of distinct categories is a metric that is used in gauge R&R studies to identify a measurement system's ability to detect a difference in measured characteristic. The number of distinct categories represents the number of non-overlapping confidence intervals that span the range of product variation. The Measurement System Analysis Manual, published by AIAG, recommends that 5 or more number of distinct categories indicates an acceptable measurement system. Usually, when the number of distinct categories is less than 2, the measurement system is of no value for controlling the process because it cannot distinguish between parts. When the number of distinct categories is 2, you can split the parts into only two groups, such as high and low. When the number of distinct categories is 3, you can split up the parts into 3 groups, such as low, middle, and high. Minitab calculates the number of distinct categories by dividing the standard deviation for parts by the standard deviation for gauge, then multiplies by 1.41, which is equal to square root of 2. That is, NDC is equal to sigma p upon sigma m into 1.41. Sources of process variation. The observed process variation is broken into two sources. One, part-to-part variation. This is the variability in measurements across different parts. Ideally, difference between parts, that is part to part, should explain most of the variability. And 2, measurement system variation. Measurement system variation is all variation associated with the measurement process. Potential sources of variation includes gauges, standards, procedures, software, environmental components, and so on. It includes variation due to A. Repeatability and B. Reproducibility. Reproducibility can be split into two sources. Operator, the variability in measurements due to different operators. And operator by part, the variability in measurements due to different operator and part combinations after considering part and operator separately. This is all about concept and terms.
Right? So we had seen some of the concepts from the measurement system analysis. I can totally understand that if you're first time learning about the measurement system analysis, some of the concepts might be difficult for you, but just understand simple concepts here. What is a true value? Then what is a reference value or standard value? Or we can also talk about the accuracy and precision, bias and linearity. So these are the some concepts that we need to understand during the start of this, right? Now, the once we understand what is the importance, right? Now, why it is important? Because whatever the data that we are going to collect, whether that data is accurate or not, and based on that, whatever the actions that we are going to take, whether that actions are effective or not, for that purpose, our measurement system must be capable. Now, let's talk about the second part, which is about what are the different tools in measurement system analysis and what is the correct sequence that we need to follow during learning of this, right? Because there is a misconception like measurement system analysis only consists of the gauge R&R. Yes, gauge R&R study is a part of it, but it also consists of many tools. And before even start gauge R&R study, we also need to perform some of the tools from the measurement system analysis, right? So that tools I'm going to explain. And it is a part of tools and sequence that I'm going to share with you today, right? Now, when we talk about tools and sequences to learn the MSA, it's broadly divided into two areas. The first one is depending on the type of data, whether our data is continuous data or attribute data. Now, for your information, if you don't know what is a continuous and attribute data, continuous data is a data that is always expressed in terms of fractions like weight, length, and attribute data is a data that is always explained in terms of whole number, like how many number of defects we are having, right? Now, If our data is continuous, then we are having 7 tools from the measurement system analysis that we can use to check whether our measurement system is capable or not. And when we are having the attribute data, we are having 2 tools that we can use to check whether our measurement system is capable or not. Now let's only talk about only the continuous data. As we had seen during the performing the measurement system analysis, gauge arenda study is one of the most important tools that we are using. But even before to start this gauge arenda study, there are 2 important tools that we need to use. The first one is a type 1 gauge study, and the second one is linearity and bias study. This is also called as gauge linearity and bias study. Now, this type 1 gauge study is used to check whether your measurement system is capable or not. Now, when we are performing type 1 gauge study, we are basically understanding what is a bias and repeatability present into our measurement system. Whereas when we perform the gauge linearity and bias study, again, it is used to check whether our measurement system is capable or not on 2 important metrics, which are the linearity and bias. If the type 1 gauge study and gauge linearity and bias study results are okay, or we can say they are indicating your measurement system is capable, then and then only go for the gauge arenda study. That's a very important thing, because if your measurement equipment is not okay, then it is really, we can say, difficult to understand the variation into the parts, the variation into the operators, right? Or whatever the results that we are getting also is a questionable. That means whether that results are accurate or not if our measurement equipment is not correct. So the first thing, we need to ensure our measurement equipment is correct. And for that purpose, we need to use these 2 important tools, type 1 gauge study and gauge linearity and bias study. We can also use this third tool, gauge create gauge arenda study worksheet. Now, these are the part of the gauge arenda study that we are going to perform. Now, this create gauge arenda study worksheet is used to collect the data for gauge arenda study to analyze it in a meaningful way. That means to perform the gauge arenda study, we need to collect the data in a certain sequence, right? And that sequence will be decided by this gauge arenda study worksheet. So we need to use this tool to design the worksheet so that we can analyze our measurement system. Once we create gauge arenda study worksheet and once we collect the data, then we can use the gauge arenda chart to assess the differences in measurements that can be between the different operators and different parts. We can also use the gauge arenda study crossed, gauge arenda study nested, and gauge arenda study expanded. So there are 3 types of gauge arenda study that we can use: crossed, nested, and expanded. Now, what are the applications of them? Let's understand that in detail. Gauge arenda study crossed is used when to assess the variation in your measurement system, and every operator is able to measure each part. That means the operator and parts are crossed. Each operator is going to measure all the parts into the measurement system analysis. In other words, we can say operator and parts are crossed. That's in that case, we are going to use gauge arenda study crossed. But in some cases, we are having the destructive testing. That means the one operator is not going to measure the second part next time, right? Because the part has, due to destructive testing, it has no value. It has broken down, right? In that case, we are going to use the gauge arenda study nested. Now, the third option, the third tool as a part of gauge arenda study is the gauge arenda study expanded. This is also used to assess the variation into our measurement system. But the importance of this gauge arenda study expanded is we need to use it when we are interested in checking the variation into our measurement system in addition to operator and part. Like we want to check the environmental factors, the impact of temperature, the impact of humidity, the impact of noise level. So we need to extend our measurement system analysis to the factors other than operator and part. In that case, we are going to use this gauge arenda study expanded, right? So these are the 7 tools that we are going to use for the continuous data. Till the time, if you are having any questions, please put that into the comment box and I will love to answer all your questions related to this measurement system analysis. So this is for the continuous data. Now let's understand what are the tools that we can use when we are having the attribute data. When we are having the attribute data, there are 2 tools. The first one is we need to use that tool to create the attribute agreement analysis worksheet. similar to the worksheet that we are going to create for performing the gauge and study, crossed, nested, or expanded. We need to create attribute agreement analysis worksheet first to collect the data for attribute agreement analysis and to analyze it in a meaningful way. Once we collect the data, then we need to use this tool, attribute agreement analysis. By using this tool, we can understand what is the variation into our measurement system, what is the variation between the consistency of the appraisers. In case of this attribute data, we are calling operator as a appraisers. Now, what are the things that we are going to study here? There are three things. We are going to understand what is a variation in consistency of the operators within themselves, because we are going to check the part number of times. So the first time operator is or the appraiser is saying the part is good, but whether the second time same operator is saying same part is good or bad, that we are going to check. So we are going to check what is the agreement within operators, within appraisers. What is the agreement between appraisers, and what is the agreement of appraiser with respect to the standard. So all these that we are going to study here. For that purpose, we will be getting the statistic called as a kappa, and depending on the value of kappa, we are going to see whether our measurement system is capable or not. In case of the variable data, we are going to calculate the gauge and study value, and based on that, we are going to see whether our measurement system is capable or not, right? So these are the tools and techniques that we are going to use as a part of measurement system analysis. So this is the second part. Let me see if you are having any questions till the point. Okay, till the time there are no questions, great. If you are having any questions, please put that into the comment box and I will answer all your questions. Now let's go to the third part. The third part is about, once we understand, okay, what is a sequence to learn and what are the tools and techniques which are available into this measurement system analysis, but what is the sequence that we need to follow? How we can achieve the expertise into each of these tools into the measurement system analysis, right? So that can be a question in your mind. And that's why we are going to learn how we are going to use the supporting data. What is the system that we are going to use so that we are becoming an expert into each of these measurement system analysis too. So let me share that with you. Okay. So to have the system, the first important thing that we must have the supporting data, or we should need to collect the data from our field, right? So we need to learn the system regarding each of the tools so that we can have the clear understanding of each of the tools. And I'm also going to explain what is a source to learn this measurement system analysis with handholding. If you want to learn entire all these tools with lifetime access of the content and with lifetime validity, with mentoring support, which will be given to you every single week along with community support, then you can simply visit here successfulcareerhub.com and see the course measurement system analysis and you can enroll there. Okay, now let's talk about the system here. There are 6 steps that we need to follow during learning of every tool that I have explained, right? I have explained you the tools from the various, or we can say the variable measurement system analysis and attribute measurement system analysis. Each of the tools that when we are going to start the learning, we need to follow this 6 steps approach. The first question that we need to ask, when to use that tool? Like for example, when to use the gauge and study crossed, when to use the attribute agreement analysis. So we need to understand what is the importance of that tool, when to use it. Second, what are the hypotheses in it? As we are going to use the statistics to interpret the results from whatever the tool that we are going to use, we also need to understand some statistical part of it. And it is starting with hypothesis. Because during the use of every statistical tools, we are having some hypothesis. And here we need to understand what are the hypotheses before the use of any tool into the measurement system analysis. Once it is clear to you, then understand what are the requirements or what are the data considerations when we are going to use that tool into the real life. There are some consideration or requirement before even use of every tool into the measurement system analysis. We need to understand all of these tools. In next step, take a practical example to understand it in detail. So you can go into the field, you can collect the data, and you can use this tool to understand what is the real practical implication of this. Then we need to understand what is the procedure to perform it in Minitab, Sigma Excel, and Microsoft Excel. Yes, I am also having the template for the Microsoft Excel, so you can also perform this measurement system analysis by using the Microsoft Excel. But before that, we need to understand all these importance. When to use it, what are the hypotheses in it, what are the data considerations, then collect the data into the real life, or you can directly use the data that is available into my system, and you need to follow the procedure to perform this each of the tool into the measurement system analysis. Once you perform, once you use this procedure, you are getting some results. Now it's time for the interpretation of these results. Have the detailed interpretation of the results and take the actions based on that, right? If your measurement system is capable, then absolutely fine. You can use that measurement system to collect the data along the causes of your problem or to identify the root cause of your problem. But if your measurement system is not capable, then you need to work on your measurement system first, right? So the different course of action that will be come out of it. So we need to take the actions based on the interpretation of these results. This 6 steps approach that we need to follow. You can also take a screenshot of it or you can make a note of it. It's a very important steps during learning of every tool into the measurement system analysis. Right, now let's come back to here to check whether you're having any questions. Okay, no questions are there. Great. Now, when you're going to learn this measurement system analysis by collecting the data, during the initial days, you must have the handholding support as well. Because whatever the interpretation that you are drawing from this data, that must be accurate, right? So you must have the subject matter expertise to understand what is the exact this interpretation of the results and what is the practical meaning of it. For that purpose, you must have the handholding support. And as a part of my community, I'm providing 3 ways of handholding support to every single individual who is getting into the part of my community. Now, this will be with the lifetime access of the our community. We are having the Telegram community where you can post all your questions and get the answers to them as per your requirements. Then we are having the weekly mentoring calls that is happening every single week, and I'm going to answer all the questions from our community, whether it is theoretical questions or practical questions. In addition to that, to speed up the support, we are also having the live discussion and mentoring calls as and when you need it. For example, if you are having the calls on every Friday, and if you want to discuss that with me on the Wednesday or Tuesday in between, then you can also schedule a call with me and we can discuss that and I can clarify all your queries. To extend this support, we are also having this live discussion and mentoring calls. So please make sure that when you are learning this, you must having the handholding support so that at the time when you are having the questions, you can also get the answers to your questions there. Okay. So this is all about the introduction. What is the importance of this measurement system analysis? Now, do you have any questions for me related to this measurement system analysis or any tool, any theoretical or practical question that you can have with respect to the measurement system analysis? You can ask here and I'm ready to answer your questions. Thank you so much and see you in the next live stream.